Hello again, welcome to another lesson in geometry. Today we are covering section 2.6, Proving Angles Congruent. So complete each statement with proof or prove. So Galileo wanted to prove that the planets revolve around the sun. Okay. His observations and discoveries supported his theory, but they were not proof of it. Okay, so he used inductive reasoning to try to think about how it worked, and he made some conjectures that the planets do revolve around the sun, but he could not prove it. He didn't have any way of showing it at the time. Okay. We weren't able to do that until we were really able to get into outer space and show it, or you could think of they proved it with physics later on. Okay. All right, so vocabulary builder here. Theorem is a conjecture or statement that you can prove true. So we'll use deductive reasoning to prove it, okay? We'll take known facts and stuff and put them together, okay? All right, so you can use definitions, postulates, properties, and previously proven theorems to prove new theorems, okay? So we take all the stuff we already know, including our agreed upon definitions, even though are undefined terms, postulates which we can't prove, properties that we know already, and previously proven things that we can use, okay? All right, so write T for true or F for false for each one. A postulate is a theorem. This is false. You cannot prove a postulate. A postulate is something that we agree upon, some of the basic building blocks, okay? So for instance, one of our postulates was two lines can cross at exactly 1 point. That's the maximum they can do. We can't prove that because we have to look at every example of two lines ever we could come up with. And there's billions and billions, so nobody could sit and do it. So we use inductive reasoning to come up with that postulate, but it's not proven. Okay? A theorem may contain definitions. This is true. We can put definitions in the theorem. Okay, and an axiom is a theorem. This is false. We way back in chapter 1, section 2, we learned that postulate and axiom were the same word, or different words for the same thing. Okay. All right, so complete each statement with lines, planes, or points. So here's some of the postulates from chapter 1 that you really need to know. And I don't mean you're going to memorize them by postulate 1.1. I mean you're going to memorize them by this statement that comes after. So through any two what, there's exactly one line. This should be points. So through any 2 points, there's one line. Okay. If two distinct lines intersect, they intersect in exactly 1 point. Okay. If two distinct planes intersect, they intersect in exactly one line. Notice in those cases, number 7 and 8, they don't have to intersect. Through any three non-collinear points, there's exactly one plane. Remember, the minimum number of points it takes to define a plane is 3, and they can't be in a line. On the second page, we meet our first theorem, and our first theorem is the vertical angles theorem. And you can memorize it by that, or you can also memorize what it says, which is vertical angles are congruent. I usually go with the second thing, okay? All right, so remember, a theorem means it's something that can be proven given our known facts and agreed upon facts, okay? So we can use our postulates and definitions and other theorems to prove it, okay? So if angle A and angle B are vertical angles, then the measure of angle A is 15, and the measure of angle B should also be 15, okay? So we're using our theorem here. We didn't prove it. So using the vertical angles theorem, got it. So here's another one. What is its value? Circle the word that best describes the labeled angle pair in the diagram. So these two were formed by crossing lines, and we get them opposite sides of each other. So these are vertical angles. Okay. Circle the word that best describes the relationship between labeled angles in the diagram. These angles are going to be congruent. They certainly are not perpendicular, and they are not supplementary. So lines are perpendicular and angles that are supplementary add up to 180, but those will not add up to 180 most of the time. All right. Use the labels in the diagram to write an equation. So since our vertical angles theorem says vertical angles are congruent, we never proved it yet, though, do take note of that, then we can use that information here and say 2x plus 40 is equal to 3x, and then we could solve. So we could subtract x to both sides to get x equals 40. Okay, and then that's it. That's the value of x. Okay. Notice if we plugged it back in though, 3 times 40 is 120, 2 times 40 is 80, plus 40 more also makes 120. So both angles are congruent. So the value of x is 40. All right. So here's our proof. Proof using the vertical angles theorem. So we're going to use the vertical angles theorem to prove the following. We want to prove that angle 1, if angle 1 and angle 2 are congruent, we want to prove that angle 1, 2, and 3, and 4 are all the same. Okay? So write a reason for each statement here. So angle 1 equals angle 2 is the given here. So that's what they told us in the beginning. They said, hey, angle 1 equals angle 2. So that's our given. Okay? Our second statement is angle 1 is equal to angle 3. So this is going to be vertical angles are congruent. That was the theorem that we had up above. You could call it the vertical angles theorem if you want, okay, but I'm going to go with what it means because it helps me memorize it for later. Vertical angles are the same, okay, they're congruent. And then angle 2 and angle 4, that's the same thing also. Vertical angles are congruent. So we look at our picture here, we can see that 2 and 4 should be the same, and 1 and 3 should be the same, okay? All right, so now how do we take that stuff and turn it into 1 equals 2 equals 3 equals 4? So let's see. So here we have 1 equals 2, and here we have 1 equals 3. So this is a transitive property. 3 equals 2, or 3 is congruent to 2. This is hypothesis, or the equality 1 and 1. We can cut out the middleman and say 2 and 3 are the same. And we can do the same thing here using 2 and 4 if we circle them in red. So 1 and 2 and 2 and 4, so we can say that 1 is the same as 4. So we already knew 1 and 2 are the same, and now we just proved that 2 is the same as 3, so that's good. And then we can see that 1 and 4 are the same, so we can use the whole thing, so we can get everything that we want. So 1 is the same as 4, 1 is the same as 2, and 2 is the same as 3. So this is going to be our transitive property of congruence. Okay. All right. So we redid some of these backwards in there. So 1 is 2 and 1 is 3. So we're saying that really 1 is 2 is 1, and so like this. Sorry, let's try it again, writing it out. 2 is 1, and 1 is the same as 3. Cut out the middleman, and you can see 2 is 3. There's our transitive property. So now I know 2 is equal to 3, and we can do the same thing with 2 and 4. So 1 is congruent to 2. 2 would be congruent to 4. So I cut out the middleman, I can see 1 is the same as 4 also. So I already had from the given 1 was 2. Now I have 1 is 3 from this part, and 1 is 4 from that part. Okay, so theorem 2.2 is the congruent supplements theorem. So if two angles are supplements, so that means two angle supplements. What does supplements means? Remember, that means their sum is 180 degrees of the same angle. So two angles are supplements of the same angle. So this guy and this guy are both supplements with this one. Okay? So these two, the blue and red, are supplements, and the green and red are supplements. Okay? Then the two angles are congruent. So that means the blue and green one are supposed to be congruent to each other. So these two are supplements. These two are supplements. And if that's the case, then blue and green should be congruent. Oh, that's supposed to be a congruent sign, but it sure doesn't look like it. Okay? So that's what it says. All right? So if angle 1 and 3 are supplements, that's angle 1 and 3 are supplements, and angles 2 and 3 are supplements, then angles 1 is congruent to angle 2. Okay, so we completed the diagram to show that. And here's an example. So if angle D is 135 and angle G is 45, so these two are supplements. Okay, And also F and G are supplements, so two other angles, including one of the ones we know are supplements, then we know that F and D should be the same measure. So the measure of F should be 135. Okay? If angles A and B are supplements and C is 85, and the measure of B is 95, then what is the measure of A? So here we go. A and B are supplements. So it's something like this. These guys add up to 180. And the measure of angle C, somewhere over here, is 85. And the measure of angle B is 95. So notice that B and C are supplements also. So if A and B are supplements, and B and C are supplements, and B and C are supplements because we can see the numbers themselves and add them up to 180, okay? Then that means A and C should have the same measure, and since C is 85, A should also be 85. Now, if you just stop and think about it for a second, we didn't really need that. A and B are supplements, and they told us what B was. So we know what A is anyways. We don't have to know what C was. All right? Now, this is where we're going to prove one of those theorems that we had. So we're going to do a paragraph proof for the vertical angles theorem. So we're going to try to prove that vertical angles are congruent. And we're going to, instead of doing a two-column proof, we're going to write a paragraph proof. That just means we write a bunch of sentences and we use the thing on the left side, the statement, and the thing on the right side, the reason to write the sentence. So we just kind of take the paragraph proof and put it together by doing the reasons and statements from a two-column proof. Okay. All right. So here's our first sentence. The measures of 1 and 3 are vertical angles because it's given. Okay. So we're just circling over here. All right. So you can think about this. In a two-column proof, it would have had 1 and 3 are vertical angles, and over here on the right side, it would have said given. So we just put because it is given in between. So because it is, it's kind of like the break in the two-column proof, that line. All right, so angles 1 and 2 are, let's see, 1 and 2 up here. They form a linear pair, so they are supplementary because they form a linear pair. Okay. Angles 2 and 3 are supplementary because they form a linear pair. Now, measure of angle 1 plus the measure of angle 2 equals 180 because the sum of the measures of supplementary angles always makes 180. Okay? So we use this part on the left side of our two-column proof, and this part over here would be the right side, the reason for it. Sum of the measures of supplementary angles is always 180. All right? And then we know the same thing with 2 and 3 because supplementary angles always add up to 180. And then by the, let's see, reflexive or transitive property here. So measure of angle 1 plus the measure of angle 2 is supposed to equal the measure of angle 2 plus the measure of angle 3. This is our transitive property. Here's where it's coming from. So we have 1 and 2 equals 180. And then we read 23 backwards. It says 180 equals 2 and 3. So we'll cut out the middleman and the equalities of 180, and we can see 1 and 2 equals 2 and 3. Okay. And then by the, well, let's see, what's the same on both? Measure of angle 2, it went away. So by the subtraction property of equality, we can get angle 1 equals angle 3. And then blank angles are the same. So, angles with the same measure are congruent. Okay, so angle 1 is congruent to angle 3. So we proved if two angles are vertical, then they're congruent. Okay, and that's what you have to. That's why we're able to call that the vertical angles theorem, because we can prove it using postulates and definitions and previous known proved theorems. Okay, all right. And our last thing on this page, we have a new theorem here. It's the congruent complements theorem. It's very similar to the congruent supplements theorem, except we say the two angles, complementary instead of supplementary. So if two angles are complements of the same angle, or of the congruent angles, then those two angles are also congruent. So angle 1 is supplementary to 165, and B is the complement of a 75-degree angle. Circle relationship between angle A and B. So A is the supplement of 165. So we have A over here. Supplement of it, that means it's going to add up to 180. So we have 165 degree angle, and then we have angle A, and that means angle A should be 15, I think, right? And then we say angle B is the complement of a 75 degree angle. So we have a 75 degree angle, and we know angle B is right here, and they're complements, so that should have been a 15 degree angle. All right. So circle the relationship between A and B. Well, A and B should be congruent, okay? Since A had to have been 15, its complement is also 75. And since A and B have the same complement, they are equal to each other, okay? So they should be congruent. Let's flip it over. We have one more theorem left, or actually two. Theorem 2.4, all right angles are congruent. That makes sense. If it's a right angle, it measures 90, and all measures of that 90 should be the same. And if two angles are congruent and supplementary, then each one is a right angle. So if they're congruent and they're supplementary, so we have two angles, and we want them to be congruent and supplementary. So let's draw them as a linear pair first. If they're congruent, then they both have to be 90, so they could add up to 180. Or we could draw them separately. And here's two congruent angles, and the only two that are possible that are also supplementary. So they're both 90. So each one is a right angle. So if R and S are right angles, then angle R is congruent. I can't tell on the smartboard. What does that say? Congruent to angle S. That is congruent symbol in there. Okay. And if H is congruent to J, and H and J are supplements, then the measure of angle H is equal to 90, which is the measure of angle J also. Okay, so this one comes from theorem 2.4, and this one comes from theorem 2.5. So all right angles are the same, and if two angles are congruent to each other, then they're both, and supplementary, then they're both right angles. Okay. All right, so pause the video here, and then do the lesson check yourself, and then come back and make sure that you understood. So on our lesson check, we had what were the measures of angle 1, 2, and 3. And we have some stuff to help us get there. So cross out the theorem you cannot use to help you find an angle measure above. I don't think we could possibly use the supplements theorem. Supplements theorem is talking about two angles that are supplementary to the same angle. And none of these angles are supplementary with each other at all. We're definitely going to use the vertical angles theorem. And if we really wanted to, we could use the congruent complements theorem because a lot of these pairs of angles add up to 90. All right, so what's the measure of angle 1? All right, so I'm going to use the vertical angles here. So 90 is, these are formed by opposite rays, so we have a 90 down here, and that should be congruent to angle 1. So angle 1 should also be 90. All right, to get angle 2, I'm going to do the same thing. I'm going to do the vertical angles. So I know that angle 2 is vertical with 50. So these guys should be equal. Vertical angles are always congruent. That's the vertical angle theorem. And then let's see, just for the fun of it, I could do 3 and 40 are vertical angles, and I could use the vertical angle theorem again. But instead, I'm going to say that 3 is complements with 50, and 40 is complements with 50. Therefore, 3 and 40 should be the same, and that uses the congruent complements theorem. So that's why we could use that congruent complements theorem. 3 and 40 are both complements with 50-degree angle. Not the same 50-degree angle, but a 50-degree angle. Okay. All right, lesson check. Part 2. If A and B are supplements and A and C are supplements, what can you conclude about B and C? So this is directly from our theorem that if two angles are supplementary with the same angle, then they are congruent. So B is supplementary with A, and C is supplementary with A, so B and C should be the same. All right. So let's do 34. So since angle A and B are supplements, then the measure of angle A plus the measure of angle B should add up to 180. Since A and C are supplements, the measure of angle A plus angle C should be 180. And by the transitive property of equality, That's saying this, reading it this way, these two add up to 180, and reading that one the opposite direction, 180 equals those two, we can cut out the middleman of 180 and say that the measure of angle A plus B, that's this part, equals the measure of angle A plus C, that's the other part. Okay? And then by the subtraction property of equality, we can take away measure of angle A from both of those and just say the measure of angle B equals the measure of angle C. And that means the angle B is congruent to angle C. So we proved what we thought. B and C are congruent to each other. Okay? And this also proves our supplements theorem. Okay? All right, check off the vocabulary words that you understand. So hopefully you've got theorem down, a paragraph proof, which is just taking a two-column proof and writing them together, each line of the two-column proof as a sentence. Complementary, supplementary, and right angle. Those you should really have down. And then rate yourself. And once again, if you fall down here, watch the video again. It will help you. Okay? I'll see you in class next time, and then we'll prepare for our test.